Hi, I welcome you to this battery design for EV application section. In this session, we are going to discuss in detail about what is the battery basics and how we can understand the parameters of the battery and how we can model this thing with Matlab Simulink. So keep engaged with this entire sessions. So definitely you will get to know about the complete idea about the battery. So if you take a battery, so battery is a device which is used to convert from chemical energy into electrical energy. So here the lot of chemical materials will be there. So whenever you try to pass the take a power from the battery, or if you apply voltage to the battery, then the chemical process may happen. So due to that chemical process, we are getting the electrical energy. So what is the types of battery? So there are majorly there are two types. One is called the primary battery and secondary battery. The primary battery is nothing but non-rechargeable battery. Just it's a use and throw battery. Similarly, that the secondary batteries are the rechargeable battery. Under this rechargeable battery, lot of types are there. So in this particularly, what it is happening inside the battery. If you take a battery for the EV, for whatever the batteries used in the EV applications, so when you try to load the battery, then the flow of electrons may happen. So due to that, the chemical process may happen inside the battery. So from this image, you can easily understand the usage of the battery. So straight away, you can connect the load to the battery, then the load will get energy from the battery. And so like this. So if you take this is as a equivalent circuit, so there is a voltage source, and in addition to that series and then parallel resistance and capacitance will be there. For each and every material, so it has its own resistance and then capacitive property for that particular material. So here in the Matlab, we can simulate the same equivalent circuit and how we can get output and so the demo is scheduled. So please don't skip the video. So please understand everything. And so the types of batteries which is used widely in the electric vehicle applications, so the lithium-ion, lithium phosphate, and nickel metal hydride batteries, and then lead acid batteries. The lead acid batteries are actually for the hybrid vehicles, and then for battery EVs, small applications we can use it. For as a main battery, so lithium ion or lithium phosphate will give you the excellent performance for this EV applications. Why? Because the individual cell battery storage is a huge value, so than that other material. So till 3.6 voltage can be stored on a single battery cells. So that's why this lithium phosphate and lithium ion technology has occupied this entire market. And if you take this image, see, actually in the first time itself, for the lithium ion battery only, the flow of electrons, that is the temperature rise, is controlled with the help of flow of electrons. Whenever you try to charge the battery and the first time, then the small medium will be generated. So inside the material, inside the battery. So due to that medium, the temperature is highly controlled. So due to advantages of the temperature control within this battery, then this lithium ion and the lithium phosphate occupied this entire EV market for the battery segment. And these are all some of the batteries used widely in the electrical vehicle market. So you see here, if you take a Tata Pyrus vehicle, so here a 4.4 kilowatt lithium ion battery is used, and again it took 1.5 hours. So again this data is for 2020 April, and after that there are some lot of changes has made, but these are some basic idea to understand how much battery is required for various vehicles. Some batteries use 16 kilowatt, and some batteries use 70 kilowatt, and some batteries use 44 kilowatt. So like that, that is the battery capacity which is widely used in this electric vehicle applications. So what is the battery parameters? See, if you take a battery parameters, So these are all the parameters. If you can get these data from the data sheet of the any battery. So first parameter is that SOC, that is called the state of charge, and depth of discharge. See, what is SOC? So the SOC is nothing but the fraction of total energy or battery capacity that has been used overall the total available from the battery. So that is that it shows that remaining capacity which is available on the battery. So if you take any mobile, so there will be a percentage shown on your mobile. So that is the remaining capacity, so that you can use it for the remaining time, and which is the balance amount of energy available on the battery. And similarly, depth of discharge. It's a depth of discharge is nothing but percentage capacity of the battery which has been discharged relative to the overall ideal capacity of the battery. And see here, generally the depth of discharge should be allowed from 20% to maximum 80%. You should not allow more than 100%. Sorry, more than 20%. You should not allow to 0%, from 20 to 0. And state of health. The state of health nothing but measurement of your ability, battery ability to store and deliver the electrical energy. So this is a state of health. And similarly, the C rate nothing but which is the value to store the energy as well as to discharge to store the current as well as to discharge the current. So see, if you measure the C rate of the battery, then this C rate will be mentioned on the data sheet. If you take that C rate, which means that if it is mentioned 1C, then you can charge the battery as well as you can discharge the battery for 1 hour. Similarly, if you take a 5C battery, then within 12 minutes that the battery can charge it as well as the battery can discharge the current from the battery set. So that is a C rate. Similarly, if you take this graph, if your battery is in 1C, then see here 1C nothing but 1 hour will take to charge the battery as well as the discharge the battery. Similarly, if you take a 0.2C, then it took 5 hours to charge as well as the discharge of the battery. So like that we can easily understand the battery parameters. So now let us check a battery equivalent circuit, how it is modeled in the Matlab Simulink. Just to go to the Matlab and take this example, so which I have already modeled. So these are all the Simscape component. So just take a DC voltage source. So here we can mention the voltage cell battery. So 1 volt we took. And similarly, this is the current sensor, and these two are the series resistance value of the chemical properties, and this is the capacitor value, 5000 farad. It's again it's a typical value of the chemical properties. And again this is the variable load, so sometime it will be zero resistance and sometime it will be the highest resistance, so that we can understand while you change the load how the current from the battery and then voltage from the battery is varying. And see here, this is the input for the variable resistance, and so this is the PS2 Simulink converter. So because these are all the Simulink Simscape components, and these are all the Simulink components, so you can connect via this block only. And see here, this is the current, we are taking from the battery, so that's why we are adding the minus value, and we are calculating for the minute. So that's why we took 3600 minutes. And so this is the integrator to calculate the ampere hour. And so now we are calculating current as well as that voltage block, and if you multiply that one, then you can get it as a watt hour. And from the current data itself, you can take it ampere hour. So the ampere are nothing but if you divide that entire value in terms of seconds to hour, that's why we are adding that 1 divided by 3600. So we can get it as a ampere hour value. So just to run the simulation. Just to run the simulation, so we can get the output and we can analyze the output. Now the simulation has finished. So just to check, see here, so initially that 33, that is called ampere hour. So initially the load resistance is very low, so that's why the current is not at discharge. And so after that the resistance has improved, and by changing this value, so by changing this value, so initially that till 100 it's not a zero value. After that it's one resistance 1 ohm is applied. So due to that we are receiving the power. So like that we can understand, we can develop a equivalent circuit for the battery. But in the MATLAB there are again few more batteries are there. So simply just search the battery component in the Simulink. So here you can select all the components. You can check it. Both the sim power system as well as simscape battery models are there. So some battery will have all the datasheets parameters, and the simscape batteries will take it into the physical properties. And so this is the sim power system block. So let us check one by one. Just to go to the new simulation. Just go to the new simulation and take a battery, and see here you can choose the battery type and then battery ratings, whatever you want. And before, let us identify the terminal. So the M nothing but the measurement of the battery. So just rotate the battery, and we can try to add the value. So now just to take a bus selector, and now you can measure the battery parameters. Just remove the signal and add whatever you want. So now we have added the SOC block and then voltage and then current measurement block. And now just to take a resistance block to load the battery. Just to take series RLC branch. Just choose resistance alone. Now the idea is already the battery has charged to 50%. So the battery SOC is about 50%, and nominal voltage is 12 voltage, and the rated ampere is 5 ampere. So just I am taking some typical value, so you can choose any of rated values. Just to connect the resistance here, and now you just need to power guide block, because since it's being a Simulink power system, so you have to use that one. Now take a scope block, yes, just to connect accordingly. And now we can verify the simulations. Just save the simulation. Just save the simulation, and Run the simulation for a minute. Now the simulation has finished. So just to open the scope. So let us understand the SOC will decrease from its initial position. So let us check. So we have used 3 different scopes. So just to change the scope value and to understand the signals. Yes. So now the SOC is reduced. Similarly, the current taken from the battery and then voltage, terminal voltage is started to reduce. So now just we did just connected the load to the battery. The load from the load battery we are receiving power. So in that case, the battery capacity may get reduced. Similarly, if you apply the voltage to this battery, then what we can observe how things can be changed. Just change to the source. So since it's being a 12 voltage, so you have to apply voltage higher than this one. So then only the DC in real time the voltage will be passed. So just to take it 12.6 voltage. So now let us observe what it is happening. Because there is a battery capacity is only 50%. So now the simulation should give you the higher increase the SOC. Here we have applied very small voltage. If you change the voltage, because 12.6 is not enough, so just increase to 2 voltage higher. Yes, here the SOC started to increase it. So like that we can, if you load the if you connect the load to the battery, then we can take a power from the battery. If you connect the source to the battery, then the battery will get charged. So like that we can understand charging and then discharging. So now the point is we have to develop a charger and then discharge circuit to charge the battery. So keep engaged with this entire session, so you will come to know about those things. So now how we can configure the battery. So there are 3 different types. One is called the series and then parallel, and series and parallel. So as we know that in the series combination of any voltage sources, then the voltage can be added, the current will be remain same. And whereas in the parallel combination, the voltage will be remains constant and the current can be added. And the series and parallel, so both the voltages and then the current can be added, so based on the configurations. So if you take a series configuration, so 1.5 voltage to 2000 milliampere, 4 sources has been added into the series. So in that case the total capacity of the source is about 6 voltage 2000 milliampere. And similarly, if you take a parallel configurations, if you configure the 1.5 voltage 2 ampere 2000 milliampere, in that case then the entire load capacity will be about 1.5 voltage 8000 milliampere. Similarly, for if you take this example, 2 sources are the series and then 2 sources are the parallel. So in that case 3 voltage and then 4000 milliampere. So this is the configuration. So by this method you can configure n number of batteries. And how we can calculate the battery for our applications. See, actually, as you know that you have to calculate the motor power requirement. To calculate the motor power requirement, you need a motor vehicle specifications. which means that weight of your vehicle and the dimensions of your vehicle and other properties called radius and then rolling resistance and then aerodynamic drag force and gear mechanisms, everything you should know. And now if you calculated the motor power requirement, so now from this motor power requirement we have to calculate the battery sizing. So generally people will call as a battery sizing. So if you take this vehicle dimensions, so from this if you take this motor as a requirement for this speed range, for 40 km per hour, if you calculate 1.8 kilowatt motor, or else for the 50 km per hour, then the motor power requirement is about 2.5 km. And this is just I took a typical value. So you have to achieve this value by this calculations. And for 100 km per hour, then the 8.1 kilowatt motor is the required motor power to move your vehicle. So now the point is how to choose the battery for this requirement. So generally, if you take this motor power, so these motors, these powers are the fractional powers. In the market, you can get it as a 8 kilowatt or 7.5 kilowatt or 10 kilowatt or 12.5 kilowatt motor. So now we have to choose the motor, so nearby range. So generally for the 8 kilowatt, to achieve the 8 kilowatt motor power, then you have to go with the 10 kilowatt motor. So now we are taking this 10 kilowatt motor as a motor component for the electric vehicle. So now we finish the second step of the EV design. The third step is the battery sizing. So how to choose the battery sizings? The first one, you have to calculate the total current consumption by the motor when it is fully loaded. Suppose if you take if you are going to use 100% 10 kilowatt as a load, then you can calculate the total current consumption. So the total current consumption is about just use the formula P is equal to VI. Then from this just apply 10 kilowatt and then 72. So now we have chosen that terminal voltage of the motor is 72 voltage. And now you have an option. You can use it for either 48 voltage or 300 voltage or 200 voltage, whatever you want, you can choose it. If you increase the voltage, here the current going to decrease it. If you decrease the voltage, then again the current is going to increase it. So like that you can choose. You have to fix any one of the value. First you have to choose the motor and you have to fix the terminal voltage of the motor. So this is again your choice to fix the parameter. And the second step, so you have to calculate watt hour calculations. The watt hour calculations nothing but if your vehicle is running about 1 kilowatt 1 hour. So in that case, the total watt hour is about 10,000 watt hour. And from this you can calculate the ampere hour calculations. The ampere hour calculations nothing but motor requires a 10 kilowatt. So in that case, if you run your motor for 1 hour, then exactly 10 kilowatt hour is requirement. So let us take this example. So in this source, earlier we used only 12.6 kilowatt, 6 voltage. The battery is not started to charge. But if we keep 10% higher than this rated voltages, then the battery took a charge. So like that, so you have to increase 20 to 30% higher than this actual requirement. Actual requirement is 10 kilowatt hour. So now you have to increase this watt hour because the battery is the source. So in that case, you have to increase 20% higher. So that's why we are adding that actual total watt hour requirement is about 1.2 watt hour. So finally, if you multiply this one, then 12 kilowatt hour is requirement. If you the ampere are nothing but watt hour, there will be terminal voltage. So this is the generalized formula. So if you if you divide the terminal voltage, then ampere hour requirement is about 166 ampere hour. So this is the battery requirement. And now we can choose the battery requirement is about 72 voltage and 166 Ah. So this is our battery requirement. So if you apply this battery to this 10 kilowatt motor, then what it will happen? So from this we can easily observe the vehicle can cover up to 100 kilometer per hour. Even though if it is covered, then the 20% energy will be balanced in the battery. So because the DOD should not be less than the 20%. So that's why we are keeping this variations. So if you keep 72 voltage 166 ampere hour battery, then we can comfortably cover this distance on the particular time. Again, this current drawn can be varied based on the drive cycle. So that is again one more important point. So that we will discuss on the integration part in the end of this series. So from this battery requirement, like 72 voltage and then 166 ampere hour, that is a battery requirement of the vehicle. From this, how we can assemble the battery? See again, if you take a lithium-ion battery, so there will be a cells. So in the market, you can get it as a cell. So the cell nothing but individual model is a cell. So if you combine that battery with different configuration, either series or parallel, then you will get a model. So now you have to model it. So as if you take a battery cell voltage is about 2.6 voltage. 2.6 voltage and ampere R is about 2 ampere. So now the requirement is about 72 voltage terminal voltage and then 166 ampere hour. So this is the battery requirement to achieve that specifications. So if you keep this battery requirement, your motor can cover 100 kilometer within an hour. So that is the maximum requirement of the motor EV. So like this, you have to model either series or parallel. You can connect the battery and then ultimately you have to take a voltage from the battery. Model is 72 voltage and then 166 ampere. Yes. So like this, you can assemble the battery. And the approximate budget for the battery lithium ion is about 2,250 rupees. For this individual model. So the individual model nothing but like for cell individual cell is about 200 rupees is the individual cell. So like a 3.6 voltage and then 2 ampere is the individual cell. So if you take a for this price is for the 10 pieces. So like that you can calculate the value. So this is again, this rate is as of April 2020. So now let us move to the battery charger design. For this battery charger design, the power electronic circuit is going to convert charge the battery from the power source, as well as we can load the battery via the power circuits. So for that one, there are a block diagram. So take this block diagram. So this bidirectional circuit is used to charge your battery, as well as that you can load the battery. So via this model you can load the battery. So now let us check one by one how the things can be implemented in the Matlab Simulink. Yeah, if you take this example, in this example the battery is modeled, and so this is the power electronic circuit. It's a bidirectional converter, and so this is the series RLC branch. So from this one we took resistance and then inductive inductance, and these are the values of the inductor model. And this is a MOSFET. MOSFET, you go to the library browser, you can choose the device of the MOSFET, and since it's being a high switching frequency, we are using this MOSFET. And so this is the filter capacitor, just a filter capacitor, 1000 microfarad filter capacitor, and the internal resistance about 0.001 ohm. And this is called load component. This load is resistance is 6 ohm. This 6 ohm is can connect to the battery, or else it can draw the power from the DC voltage source if you activate the switch. This is just a simple ideal switch. So this is the 48 voltage DC bus voltage, and if you connect, if you apply 1 here, then which means that the source is connected to the load. So the source can supply current to this load, as well as the battery can draw a power from the source. So both the process can activate. And if you remove this source from the network, then which means that the load is connected to the battery, and the battery will deliver the power to the load to activate the load. And now while doing the charging and then discharging design, see here there are two different methods. One is called constant current charging and constant voltage charging. So let us first design constant current charging. So the constant current charging, see here the current of the battery is measured and compared with the reference waveform. So now the point is 10 ampere is the maximum current maximum amount of current can charge. And similarly, this is the PID controller. So I took just a basic PI controller, and this is that integrated proportional value. And if you after the PID block, and you will get a error signal. So that is the controlled error signal. So if you apply that value to this PWM block, so this is the 10 kilohertz switching frequency, and if you apply the PWM block, then we will get a pulse. So that pulse can be connected to the top switch, and then bottom switch you just invert the battery, invert the switch, and you cannot connect the same PWM because the voltage will get short circuited. So due to that reasons, you have to invert the gate pulses. So like that, if you apply that one, so just connect the source to the network, just connect the source to this network, then we can observe both the source, both the battery as well as the load parameters. Just to take, first let us understand the load, how much load is received. See here the 48 voltage is applied, and similarly, so let us assume, let us measure whether the battery is charging or discharging. See here the SOC is 50% initially, so that's why it's started to charge from 50%, and here we are limiting the current up to 10 ampere. So this is the 10 ampere. Suppose if you are allowing 12 ampere or 15 ampere, then the current may rise to 15 ampere. So like that, we can vary the we can implement the constant current charging. Similarly, so the same amount of current can be discharged also. So just to change to the remove the source from the network. So now the battery is put under that discharge mode. So now the battery is under the discharge mode. So now the maximum amount of current will be in the positive directions. So this is called current discharge amount. So like that you can implement. So the SOC has started to decrease it. So this is constant current charging. Similarly, constant voltage as well as the constant current charging method also can be implemented. So if you take this example, earlier we have considered only constant volt current, and similarly now we are going to take it as a voltage also. So here since it's a 24 voltage battery, the source must be higher than this one. So that's why we took it as a 26 voltage is the maximum voltage. So now the point is the battery can receive at a terminal, its a maximum voltage will be the 26. So the same parameter can be applied. So just change to the 1. Let us check whether how much is the charging and then discharging behaviors. So now the source is connected to the battery, and here this is the constant voltage. Yes. So the constant voltage is about 26 voltage is the maximum voltage which can apply. So within that depend the voltage control loop, then the current will get automatically controlled. And similarly, if you remove the source from the network, then the battery will put under that discontinuous discharge mode. So similarly, this current can be discharged. So now the current will get increased because it's a discharge current, and the voltage, terminal voltage started to decrease it. So like that, we can automate the charging as well as the discharging network. So just download the example and then self practice it, and take output, and then just paste the output in the comment box. So now again one more example I have scheduled. So from this example we can understand how both can be connected. See here, the load voltage also should taken into the consideration. So earlier the voltage loop has been implemented. So now the point is, so automatically the entire system needs to be updated. See here, if what DC input is available, then the load should receive a power automatically from this battery source, from this DC source. If it is not available, so based on its value, even though if it is a 12 voltage, then it should receive a 48 voltage as the rated voltages. So like that we have to implement another loop. And see, this switch block will choose the option, that is whether the battery should run under the charging or discharging, or else the closed loop of the entire DC to DC converter should take. So it depends the input which is available here. So here the scenario can be two choices. One is that if it is a 1, then the load is available. If it is a 0, then the load is not available. If the load is not available, the source is not available, then the load should draw a power from the battery with this reference voltage. And see here, like that, this switch is modeled. So this is simple like a logical controller. If it is a 0, then this loop will get activated. If it is a 1, then this loop will get activated. So like that, the PWM circuit can be generated. If you run the simulation, so entire system will get activated. So now the source is connected to the network, so the load always will receive a 48 voltage. Here the 48 voltage. Now I am disconnecting the source from the network. So now the battery will supply the source. Battery will supply the voltage to this load. So even though if it is a battery will have only 24 voltage, but we should need 48 voltage. So for that one only, this loop will taken care. So this loop will taken care and then compare and to generate a PWM. So like that we can achieve the entire battery integration to the electric vehicle systems. And just download the simulation and then self practice it, and paste the output in the video comment box. And so this is the cell arrangement which is happened in the any electric vehicle systems. So like this, you can in the electric vehicle, the battery has been modeled. And thank you. I will catch you in the next session. If you are interested in the internship, you will get a certificate by email. For that one, you will get an internship program. So here you can join the VP group, WhatsApp group, and you will get directly. You can get a support from me. How to how to do and how to develop your own vehicle and all. So that is, the cost is only 590. The link is available in the description box, so you can get. And if you are interested, is 11th February 2023. 11th February 2023, right? So you can join over there. If you have any doubt, you can ask me. I will try to give you the answers. And this is my WhatsApp number, so you can post your queries here also. I will give you. I am here to help you. See here, after joining in the internship, you can directly go to the our LMS website. So here you can get a TV bundle. So see here, you will get a complete classes. So you can download
You can download the MATLAB simulations. You can download all the presentations, everything. You can download the PPT, you can download the simulation files, everything. You can get it in the internship. Whereas for the YouTube sessions, you can post your queries. You just follow the live sessions, and you can practice on the live only. Yes. So all the sessions are available. If you are interested, you can go and join the internship. You can download it. All the notes are available to download. Thank you, participants. Thanks for valuable time. If you have any questions, you can post me. Just take my number. This is my WhatsApp number. So 98409744408. So if you have any queries about your research activity or your laboratory requirements, you can post your queries here. Thank you, participants. Thanks for valuable time. Thank you once again.